Yep, now we're working. Okay, y'all. All right, here we go. Okay, so we are looking at number 12. It says Andrea wants to fill in 2 sections of her backyard with sod that must be purchased in 2 by 2 foot squares. If the 2 sections measure 30 by 40 feet and 60 by 80 feet, how many squares of sod does she need to buy? What do you have to do right here? We don't know? We don't know how to do this one? What'd you do? Good. That's exactly what we want to do. So what he's doing right here, you guys, is he's finding the area of each one, and then he's going to divide that by the area that 1 square takes up. That's exactly what we need to be doing right here. So it tells you the section measures 30 by 40. So you've got a 30 by 40 section. So we need to know the area of that. If you're not doing your bell ringer, you need to be doing that. We're going to submit these this week. So, okay, make sure you're doing your bell ringer with me. You will submit them, and it's free points at the end of the week. So if you don't have this done, you need to be writing this down, doing this with me. So area is 30 by 40, and what's that give you? 1,200. That's for one of the sections, okay? Then for the other section, it is a 60 by 80. So what's 60 times 80? 4,800. Okay, so with that, we want to find the total area that we need to cover. So 1,200 plus 4,800 is how much? Now, each little square of sod, y'all know what sod is, right? Like the little squares of grass when you get like a new house and they put the grass in, they bring little sods. It's called a sod. So that's a 2 by 2. So that's a tiny little piece. 2 by 2, the area that it will cover is 4, okay, 4 square feet. So you take this big number, you divide by 4, that's going to tell you how many pieces of sod you need. So what is 6,000 divided by 4? What is it? 1,500? Perfect. Good job. Okay, now, do you remember SOHCAHTOA from your geometry class? Who taught y'all geometry? Was it me? I taught some of y'all geometry. Ms. Zader. Okay. I'm not sure if Ms. Zader got to this or not. I know I did. Y'all did? SOHCAHTOA. Okay. This is sine. This is cosine. This is tangent. But this is a secant. Okay, so it is off one of the other ones. So when we're doing this, we have to, think in terms of what it is. So do you remember what the secant is? No? It's the inverse of one of them. I don't remember what it is. All of you have a cell phone right in front of you. Why didn't you look it up? Half of you are playing games. Formula for secant. It is, gives me a graph. I don't want a graph. I think I got it. It was just right there. Hold on, where'd it go? The secant is 1 over the cosine. Okay, so we need the cosine, which is the adjacent over the hypotenuse. Okay, so we want it for angle N. So who is adjacent to angle N? 4, because 4 is your hypotenuse. So your adjacent is going to be 4 over your hypotenuse, which is 2 square roots of 5. This is going to be cosine, which we do need cosine, but we're going to put 1 over cosine. So we're going to start here and we're going to simplify. How can we simplify this? 4 divided by 2 is 2 on the numerator, but that denominator is going to stay the square root of 5. Okay, so you're just simplifying. 4 divided by 2 is 2, but the radical stays on the bottom, which is not allowed. Do you remember how to get the radical out of the denominator? You multiply by whatever's down there. Because what is 5 times 5? What's the square root of 25? So on the bottom down here is going to be 5. 5 is going to be in that denominator. And then on top, 2 times the square root of 5 is just going to stay 2 times the square root of 5. Now, that is cosine. But remember, secant is 1 over that. So we're going to have 1 divided by 2 square roots of 5 over 5. Obviously, that's not one of your answers. Okay? What's the rule for dividing fractions? Instead of dividing fractions, you multiply by the reciprocal. That's right. So I'm going to multiply 1 times the reciprocal, which is going to be 5 over 2 square roots of 5. And this problem is tough. 5 over 2 square roots of 5, but then we're back to the same situation. We cannot have the square root on the bottom. So again, we have to rationalize that denominator. Who's going to do this on the ACT? No, I don't even blame you for that. I don't even blame you at all. And then 2 times 5 is going to give us 10. So we've got 5 square roots of 5 all over 10. 5 over 10 simplifies to give you 5 over 10, 1 over 2, 1/2. So you're going to have 1/2 square roots of 5, which is just going to be C. Ew. What do you do, though, when you guess? You can guess C, that's fine. But if you guess C, that needs to be what you guess every time you guess, okay? When you guess on the ACT or on a standardized test, don't jump around. You need to like go into that test thinking C is my choice or B is my choice, okay? D, whatever it is that you want to guess, you need to guess that every single time. Because look, here's the deal. If on the first one you guess A, and then the second one you guess B, the third one you guess D, then you come back to A, back to B, like you could literally miss every problem. Like you could get 0 correct. But if you choose C all the way down, at least you're going to get 1, maybe 2 correct, okay? But if you just sporadically guess, then you could potentially miss every single problem, okay? So if you have to guess, which I'm not telling you to guess on your test, but on some of them, you are going to have to guess. I had to guess on some of them, okay? So if you do, you need to pick a letter and go with it. That's not just for math. That's for everything. English, science, reading. If you're going to guess, you need to guess consistently. Now, if you can use like an educated guess and eliminate some answers, and like if your answer like that you're going with all test long is B, but B is like the stupidest answer in the world, then obviously don't pick B for that one, you know. But if you have literally no idea and it's just a shot in the dark, you need to be picking the same letter every single time because it ups your odds for getting some of them correct. Okay, I hope someone's already told you that, but if not, now you know. Okay, What does our module say we are doing today? Factoring, right? Solving by factoring. Y'all did the delta on Friday, is that right? Yes, 7.3. Lesson 7.3 is what we are working on. Let me grab my book and we will make it happen. Okay, 7.3 is on 111. Very good. Thank you. Hey, and if you're ever, like I quit putting the pages on here because most of you are with me and you've got your textbook, but if you're at home or at a friend's house and you don't have your book, you can always go to the home page and come to the digital textbook button. I know y'all probably don't even look at these anymore, but this textbook button will take you to the textbook. Okay, so if you're ever in need of the textbook, it's there for you. Then I don't know if yours would make you do this or not, but if you log in with Clever, it's just the same thing as your school login. Like it should hopefully just log you right in. I don't want to do that. I'm just going to pull my book up. Okay, so tell me about factoring. How do we feel about it? Feel good about it? I was hoping that practice would help some, and like it gives you like a platform where you had to get it right, like you couldn't get it wrong, and then they had videos and stuff, so hopefully Delta really kind of made sure that you knew what you were doing. That was my hope, at least. Okay, cool. All right, so the only thing that's different with this lesson and last lesson is now they are going to equal 0. So if you look at this problem here, this part looks the same. You've got your trinomial, you've got your x squared, your bx, and your c. All of that's the same. The only difference is now it's set equal to 0, or set equal to a number, or set equal to something. You've got an equation instead of just having an expression. So what you're going to do is, first of all, make sure it is equal to 0, okay? If it's not equal to 0, subtract or add or whatever you got to do to get it in standard form. Standard form will always look like this. Ax squared plus bx plus c equals 0. That's going to be your standard form. So that's step 1, get into standard form. Once you're into standard form, you factor this just like we factored the others. So I'm going to make this box. I've got my x squared, my negative 14. The factors of negative 14 are 1 and 14, 2 and 7. Somebody's going to be negative because 14 is negative. What sum are we looking for? We want it to be positive 5, right? So if I add these together, that's going to be 13. If I add these together, that's going to be positive 5. So who are we looking for? Negative 2 and positive 7. So we just add that in here. Doesn't matter where. You could have, oh, I do that every time. Thank you for watching me because I need that. Okay, so then we've got our negative 2x and we've got our 7x. So then we take out, just like we always do, this one's going to be x. This one's going to be positive 7 because this one's going to be negative 2. Okay? All that's the same. Nothing has changed. You're doing exactly what we learned last time. They're set equal to 0. Okay? So I'm going to set each one of the parentheses equal to 0. Set it equal to 0. This one equals 0. This one equals 0. Nobody changes. Just take whatever's in the parentheses, set it equal to 0. And then you're just algebra 1 solving, just basic solving. How do we get rid of plus 7? So x equals -7. That's one of your answers. How do we get rid of a -2? So x equals +2. That's it. That's what you're doing this lesson. The only difference is you don't stop at the parentheses. You take whatever's in the parentheses and set each one of them equal to 0 and keep going. And do you know what you just found? Do you have any idea what those are? They're the zeros. And what are the zeros when we're talking about a parabola? The roots, where it touches the x-axis. Oh my gosh, you guys are amazing. I love it. So what they are is it's like one's over here at +2 and one's over here at -7. So your parabola, that's a horrible sketch, but it looks something like that. Okay. So you've got a graph that's crossing the x-axis twice, and those are the locations. Got it? Cool. Okay, let's practice then. Let's do A together. And then that's it. I'm going to give you a couple problems for homework. You got it. All right, so first things first on A. Can we, on A, I'm like so tangled up in these wires. Okay, on A, can we take out a greatest common factor? Because that's still a thing. We're looking for that every single time. So is there anything that we can take out of that? No. So that means we're going to have to do the slip and slide method. And I'm not going to write the 0 yet. I'm just going to wait for that. I'm just going to write the trinomial. I'm going to multiply that across. What's 3 times 10? So I'm dropping the 3, and I'm putting plus 30. This is where you do your box. What goes in that first box there? X squared, and then the bottom one down here, 30. Okay. Now, we're looking for the factors of 30, positive 30, that are going to give us -17. Okay, 2 and 15 give us positive 17. How are we going to make it give us -17? Both negatives, because a negative times a negative will give us a positive 30, but when you add them up, you get that -17. Y'all, I'm like having like the nerdiest teacher moment right now, and I'm so proud of y'all. We're doing really good. Factoring is usually very hard for students, so I'm like loving this moment. All right, so top row. What do they have in common? X. Bottom row. And we do want both of them to be negative. Remember over here, we want both of them to be negative, so I'm taking out -15 right here and right here. Beautiful. So in parentheses, I've like skipped all of that, which whatever. In parentheses, we have x minus 15, x minus 2 equals 0. Now what do I have to do? Separate them and set them equal to, oh. You're right. I didn't slide that down. I almost messed up. Thank you. Because we slipped it over. Now we got to slide it down. So we're dividing by 3. What's -15 divided by 3? So now x minus 5. Beautiful. What about 2/3? We have to rewrite that one as 3x minus 2 equals 0. So what do I do with this one? Perfect. This is where I was going too soon. So we've got x minus 5 equals 0, and 3x minus 2 equals 0. How do we get x by itself here? Add 5. So x equals 5. And over here, good, Jordan. Add 2. But we can't stop there. We still gotta get rid of the 3. So so what's this x equal? Beautiful. So how many solutions do we have? 2, which means how many times is your parabola going to cross the x-axis? Yes, you guys are so awesome. Okay, I want you to do C, D, and I want you to do F, mostly because I want you to see a problem that's not in standard form. What's the first thing you have to do for F? You need to add 8 so it will equal 0. Then you can solve. You can't solve them out until they equal 0. Any questions for me? Good job. Hey, no school tomorrow. Don't even sign into Canvas. Nothing you need to do for my class tomorrow. You get this submitted before midnight tonight. Take a picture of your 3 problems, get that submitted to me, and then nothing tomorrow, and we'll be back on Wednesday. Okay?